SAS demonstration on using dates. The data set I'm using to demonstrate how SAS works with dates and some of the special SAS date functions comes from a survey of 17 patients taken in a clinic setting. The data set survey.dat is space delimited and consists of 14 variables, one of them being a date variable called dateRec, which stands for the date that the survey was received. An example of the data is shown in the comment, and notice that the second variable is a date, and this is the variable dateRec. Notice that I am using list directed input to read in the data. To tell SAS that dateRec is a date, I'm using a colon modifier, so we have here a colon following dateRec, and an informat mmddYY8 dot to instruct SAS that dateRec is a date variable. So dateRec has the form mmddYY8 dot, but to SAS it's a number, and this number is the number of days relative to January 1st, 1960. So I'm going to be doing a number of different things in this data step where I'm creating the data set survey. First of all, I'm creating a variable called last date. I want to assign it the value of number of days relative to January 1st, 1960, where our date is February 1st, 1997. So again, this last date is a number, as I said before, the number of days relative to January 1st, 1960 from February 1st, 1997. To use a date as a constant in some kind of numeric statement, we have to put it between quotes. We use the form day 01, and then for month, 3 letters identifying the month, and then 4 digits identifying the year. And then we have another quote and then the letter D. And so this is how you use date as a constant in a numeric statement. So I'm creating this variable last date. Then I am creating a variable called today, which is actually going to be today's date. The day that I'm making this video is July 29th, 2013. So today, when I run the code for you, it will be July 29th, 2013. And so if we want to just create a variable today, then we're just going to set it equal to date with an open and close parentheses. Then I'm creating the number of days between the last date, February 1st, 1997, and the date that the survey was received. And then I'm showing you 2 different ways of calculating the number of years between the last date and the date that the survey was received. The first way, I'm using the formula last date minus dateRec divided by 365.25. So that's one way of calculating years when you're looking at the difference between 2 dates. Another way that you can calculate years is with the year diff function. So we're going to use this function year diff, and anytime we use a function we're going to have an open parentheses and a closed parentheses, and then usually some kind of parameters within the parentheses. So we're putting in our parentheses dateRec, last date, and then I'm including this option called actual. And this tells SAS to use the actual number of days in each month and to count leap years. So we're creating 2 different variables for years. And then finally, I'm using a function that just returns the year. So here I'm creating a variable called yearRec, standing for year that the survey was received, and it's just going to take the year off of the variable dateRec. Notice here that I have a format statement, and I'm going to leave this format statement out the first time I run this program. So in our first proc print, there's going to be no format attached. And let's see what the output looks like. So this kind of looks interesting. All of these dates, dateRec, last date, and today's dates, are the number of days relative to January 1st, 1960. So for today's date, which was July 29th, 2013, this is 19,568 days past January 1st, 1960. The last date that we had entered as a constant was February 1st, 1997. So these are the number of days from January 1st, 1960 to February 1st, 1997. Then we created a variable called days, which was last date minus date rec. And so this is the total number of days between the time that the survey was received and the last date, which was February 1st, 1997. And these are our two different ways that we calculated years. Notice they're very close, just slightly off when we use the year diff function. Now let's run the same code, but let's attach some formats so that these dates that are shown as the number of days between January 1st, 1960 and that date are shown as a date. And so to do that, we're going to use format. The first format we're going to try, and there are many date formats that one can use. We're going to use MMDDYY10 for date rec and today, and then for last date, we're going to use the date 9 format. So let's see what the output looks like here. So notice now that date rec and today appear as dates, even though they're actual numbers. And these are the formats. We had asked for date rec and today to have the MMDDYY10 format. And for last date, we used the date 9 format. So something I also want to point out is that even though we read in date rec with the MMDDYY8 in format, and we had to do that because that's how our data appears, we can actually print out the date in a different format. So the format that we read in our date, the in format, cannot change. It has to be in the same form that the actual raw data appears. But when we go to print out our data, we can print it in a different date format. And notice here we can also print out our contents and include the formats for the date variables in our contents. So here's a proc contents of our data set survey. We see here that we have 17 observations and 21 variables because we created some new variables in our data step. And if we scroll down, we see that date rec and today have an MMDDYY10 format, and last date has a date 9 format. And that's because we used the format statement when we ran proc contents. The final thing I want to show in this example is what the frequency distribution of year survey received is. And here we are using this variable year underscore rec, which we created above using the year function. Again, what the year function does is it pulls off just the year from our date. So let's see what happens if we do a frequency distribution of year rec, or year that the survey was received. All 17 surveys were received in 1993. In this next example, I will demonstrate how we can create a SAS date from 3 different variables: a variable for month, a variable for day, and a variable for year. So here I'm using in-stream data, just some very simple 5 observations, and I'm reading in B month, standing for the month that the person was born, B day for the day they were born, B year for the year that they were born. Then I have a variable called int month for the interview month, int day for the interview day, and int year for the interview year. This is what the raw data looks like. I have a subject, Roger. His birth month was 12, his birth day was 12, and his birth year was 84. His interview month was 9, his interview day was 3, and his interview year was 94. And so I want to take these 6 different variables and turn them into 2 dates. The first thing I'm going to do is I'm going to assign the value of 15 if birthday is missing. So let's say we know the birth month of our subject and we know the birth year of our subject, but we don't know the birth day, the actual day. We're going to give it the value of 15, assuming that they were born in the middle of the month. We're going to do the same thing for the interview day. So if the interview day is missing, but we know the interview month and we know the interview year, we are going to extrapolate and say that the interview day was 15. And then I'm going to create my new variables, BIR date for birth date, and I'm going to use this wonderful function called MDY. And using this function and putting in these three different variables for month, day, and year, it's going to return an actual SAS date, a SAS number. Same thing with interview date, or the variable I'm calling int date. Again, I'm using the MDY function. And then finally, I'm now going to calculate age of interview, int age. And this is going to be the difference between interview date minus birth date divided by 365.25. And then I'm going to make use of another SAS function, int, which is just going to return the integer value. So it's just going to chop off anything to the right of the decimal point and give me an integer value for age. And then finally, I'm going to format my birth date and my interview date with the MMDDYY10 format. Notice with our raw data, we do have one subject who's missing for birthday, for B day. We have a missing value, so for that subject, Petra, we are going to fill in the number 15 so that we can actually calculate a birth date and interview age for Petra. So let's go ahead and take a look at the data. We're going to run it, first printing out the dates using SAS date formats. So here we have all of our data for our 5 observations. Roger, and we see the B month, B day, B year, interview month, interview day, interview year, and we see it put together as a date, birth date, 12/12/1984. The interview date for Roger was 9/3/1994. And the age at the time of the interview, subtracting the birth date from the interview date, is 9. Notice for Petra, we filled in her B day as 15, and we've calculated her interview age as 11. In this next proc print, I'm going to use a statement called format all. This statement here, format all. And what that does is it clears all formats from the data set within this procedure. So for this particular procedure, we are not going to see any date formats. And let's see what happens when we look at the printout without any date formats. So here the difference is that now BER date and int date are shown as the number of days relative to January 1st, 1960. So we actually see the numeric value instead of as a date format. So in the previous printout, we saw the actual date, what looks more familiar to us. And in the second printout, we see how SAS interprets that date. And once again, let's just take a look at our proc contents of this data set that we've called dates. And we see here that int date has a format of MMDDYY10. And birth date has a format of MMDDYY10 for our 5 observations. The last example that I'm going to show you is how SAS handles the year 2000 problem. So let's take a look at this simple data set that I'm inputting. I'm calling the variable check date, and it has a format MMDDYY8. So I'm again inputting check date using a colon modifier, and this is the informat which is going to tell SAS that it's a date. And then I'm going to print it out in the MMDDYY10 format. And let's see what it looks like. And you see here that when we do a 10 format, SAS assumes that the year 50 is somewhere between 1920 and 2020. And so if there was an ending of 01, SAS assumes the year is 2001 because it's sometime between 1920 and 2020. That's the default century that SAS uses. So if your year is just 2 digits, SAS is going to assume that that year is somewhere from 1920 to 2020. Let's say you were dealing with historical data and you wanted 01 or 00 to represent 1900 or 1901. To change that default, you use an option statement and then you'd set the cutoff differently. So here we're setting the cutoff equal to 1900. So now we are interested in dates that are occurring between 1900 and 1999. So the default century is normally 1920 to 2020. Here I've changed the default century to be from 1900 to to 1999. And let's run the data now with this option statement and see the difference. So here notice that the printout of dates with the year cutoff at 1900, we now see that for the third observation it's 1901, for the fifth observation it's 1900. When we use the default cutoff, the third observation was 2001 and the fifth observation was 2000. This concludes the demonstration on how SAS deals with dates.